As you try to do univariate linear regression on a new data set, you may run into problems. And in this video, I'm going to give some pointers to help you debug whether or not the univariate linear regression code that you have written is working for your data set. In pandas, once you have loaded the data into a data frame, what we can do is calculate the correlation between all pairs of variables. So I can do data.core and then run this to get pairwise correlation between all pairs of variables. So this pairwise correlation table shows that the correlation between pregnancies and pregnancies is 1. The correlation between A's and pregnancies is 0.54. Similarly, another example of something that has very high correlation is the skin correlation between skin thickness, which has 0.43 correlation with insulin. So the reason why we want to look at correlation is that if we pick two variables that have very high correlation, for example, age, pregnancies, or insulin skin thickness, we should be able to build a pretty good model that fits a line along the data where the data points appear to be correlated. The next thing we would like to do is we want to pick variables that have a lot of unique values. We preferably want to choose variables which are continuous, but at least not pick something that either has only two values or so. One way to check that is to simply choose the variable. Say, for example, I pick data, and then let's say I pick pregnancies, and then I do dot unique, and then this gives me all the unique values. And we can see that the pregnancy values range from 0 to 14. Now, this is a lot of values, but it doesn't represent a large continuous domain of values. So we probably want to avoid something like this. Even say, for example, if I print outcome, then this has only two possible values, 0 and 1. So these are not good candidates, or these variables are not good candidates for univariate linear regression. Let me print A's, and the possible values for A's are quite high. These are more than a few dozen. So these A's is not a bad candidate to perform univariate linear regression. Let's see what values insulin takes. So this has a really large range of possible values. So this also becomes a good candidate for univariate linear regression. So we can take two variables and then draw or plot a scatter plot to see how visually the correlation looks like. So I can do plt dot scatter and then pick one variable data. Say, for example, I pick blood pressure as the first variable, blood pressure, and as the second variable, I pick data BMI. So looking at the scatter plot, we can see that they almost have a slightly positive correlation. As one of them increases, as the blood pressure increases, we can see that BMI also increases. And this is also evident from the fact that the correlation between blood pressure and BMI is 0.28. So these two also become good candidates for performing univariate linear regression. The next thing that we would like to do is play around with this parameter number of epochs. So once we build a sequential model, and then once we compile it, then when we run this model.fit, we want to know how many epochs is sufficient for us to stop the training. So when I set, let's say, epoch equals to a small value like 2 and run the prediction, I see that the loss initially was 2,500, it went down to 2,300, and the MAE, that is the mean difference between my prediction and true, went from 48.8 to 47. So this is a good trend. You want to make sure that you'd want to see a trend that looks like this, a decreasing trend. This should be, in a way, overall decreasing values. So your loss should start from high value and then continue to go down. Now, You want to set the number of epochs so high that this decrease is almost insignificant. So you can start with some large values like 2 and then change it to 4 to see if it stops decreasing. I see that it is also even now continuing to decrease. My MAE also going down. So let me increase this to something higher like 8. And then I see that it went down to 874. It looks like it will further decrease if I increase the number of epochs. So this is now 874. Let me increase this to 16 epochs. I can see it has become 169, so it is continuing to increase. Let me increase this further to 32. Currently, I have 169, so let me increase it further. It went down even to 165. MAE is 9.7, so that means I can even further increase this. So let me set it to 64. So earlier it was 165. You can see that it has now even further decreased to 162.9. So there is probably even further room to decrease it. So I'm going to change this to 128. It even further went down to 158.0. So I'm going to continue to increase. I'm actually going to increase this to a very large value like 124 and then see what happens. So 154, 153, 152, it's even going down 151, 150, 149. This is good. That means my model is learning every time. It's making the weight updates and finding a better adjustment of weights and biases to give me a lesser loss and lesser MAE. So far we are at 600 of 1024 epochs. It's even further going down, 141, it went down to 140, which is wonderful, 139 even. This means we are finding a better and better fit. If you don't see such a good decreasing trend in your increasing number of epochs, that means there's something wrong. That means we have to investigate why the model is not learning. So it's 136. So let me go back and even further continue to train this. So the lowest loss that we have so far is around 136. What I'm going to do is now even train it further. So I've set the number of epochs to 5,000. The loss becomes slightly worse, but I know that it's going to go down to around 131 or even lower than that. So it's staying around 131. So this is around the time I know that it probably cannot do any better further. So that means that the epochs 5,000 that I've set is probably sufficient for me to say that we have reached an optimum values for W naught and W